So this morning I'm with Johan Besson, the MD of JD Switchgear Solutions, but of course, Johan, we know it as JD Switchgear. And the reason I'm speaking to you, Johan, is apart from the fact that it's good to renew an acquaintance with somebody you've known for many decades. What are the challenges facing young engineers in the context of industry today in South Africa? And Johan, I'll tell you why I'm asking that question. You're running a series of tutorials in electricity and control, and the one that I want to explore a little bit with you later on is the one that will appear in the July edition, which looks at containerized substations. And we'll have a conversation about what the implications of that are going to be. But I'd like to understand from you your experience of youngsters in industry in South Africa today. What are our challenges?
Yeah, and I think what a lot of youngsters face today is the fact that when they come into industry, they've not had the exposure to actually getting their hands dirty, to actually touching, feeling the equipment that they actually need to incorporate into the solutions that they produce. Very often a young electrical engineer will come and say, okay, I have to engineer a 75 kilowatt starter. He does not always understand just how much space he's going to need, what the challenges are with regards to terminations, maintenance of the equipment, the temperature rise or heat calculations that he needs to incorporate in that design. So I am a firm believer in getting the person involved in the actual production, the testing, the building of that piece of equipment, and once he has full understanding of all the aspects that go together with that, then he becomes a proper engineer because he understands the challenges with regards to installing it, maintaining it, operating it, and fault finding on it.
I think that's a very important point, because what we know about education is one thing, but translating your knowledge into a practical competence is actually a very important step, and that's clearly part of what you have to deal with. How do you translate that knowledge into dealing with something tangible? I mean, you mentioned some of the equipment that one deals with. You're right. It looks fantastic on a piece of paper, and I can do calculations around that piece of paper. But I imagine many youngsters wouldn't even recognize that equipment if they saw it in a plant environment.
That's very true. I have had many instances where we would take a young student coming freshly out of varsity or Technikon, and you hold up two pieces of equipment. He can have a contactor on one side and a circuit breaker on the other side, and he really doesn't understand the difference between the two. He doesn't know what they are. So what we very, very strongly promote is that when a guy comes out, leave him with some artisans or some test engineers or some technicians in the factory. Let him get into that environment. Let him see what the production process actually entails to build something that he has to incorporate into a solution at the end of the day. I believe that if an engineer has had the exposure to test a piece of equipment that has been manufactured. Now, first of all, he's gone through the manufacturing process. He sees what the challenges are there. He learns how to solve them. Then he takes that piece of equipment. He undergoes that practical training in testing it, in making it work, coupling the motors, running the motors, seeing what goes wrong with it, finding out in the hard way, by doing it himself, what he needs to do to solve to find the solutions to the problems that he will encounter during the commissioning phase of that particular product. So if we can find an engineer having spent 3 months or so going through the phases, manufacturing, testing, fault finding, commissioning, or testing on site, he comes away and he's an engineer that understands all aspects of that process to put a solution.
I think that's profound. I think that very often youngsters imagine that you end up in a nice air-conditioned office and engineering is about a piece of paper in front of you. It's not. Engineering is about the real world and getting your hands embedded into the real world, using the knowledge, but using it in the practical sense. And of course, that's, I think, probably what draws many of us to engineering. You get a chance to get your hands dirty. But now I want to move you on, because your series of tutorials obviously address some of these issues, but the one that I have in mind in particular is the one in the July edition where you talk about a containerized substation, thinking inside the box. Now, there's a lot hidden in that phrase, because obviously designing a substation is hugely complex engineering. It's a system that you're building. So tell us a little bit about why containerized substations make so much sense.
Well, there are very, very many reasons, but I think what I would like to do is to summarize the key advantages, if I can call it that. Firstly, when you do a containerized, or very often it's not necessarily a containerized substation. Where the word containerized comes from is because the use of marine containers lend themselves very, very nicely towards that application.
It's
But very often
packaging,
they're prefabricated because if you look at medium voltage switchgear, for example, you need an enclosure or a substation that is larger.
Yeah.
But containerized substations give you the benefit of a motor to mouse or a plug and play solution inside a factory environment. You know, one of the biggest challenges that commissioning engineers have is that there are a number of facets or parts of a project that come together. Right. You will have fire suppression, you will have UPS systems, you will have motor control, you will have medium voltage, you will have low voltage, you will have automation.
It's a complex
all of it
system.
gets integrated together. Now when you do that in a conventional brick and mortar substation, very often you have the challenges of getting all the equipment into place.
Yes.
You know, floors may not be totally level.
Correct.
You've got
Right.
all sorts of problems that manifest themselves.
Civil costs,
with the
civil
larger-
challenges.
Exactly. So where you have a containerized substation, everything is built into that containerized enclosure. It is fully tested. So the programming can be done, the motors can be connected because what happens in any manufacturer's environment, they will have, for example, for the variable speed drives and for the soft starters and for the direct online reversers, star deltas, whatever the case may be, the motors are there, they can actually connect it in the factory environment, they can address any challenges which arrive and do cold commissioning to the point where when that shipment goes out to site, it's literally a matter of connecting the cable.
That's right.
Do your hot commissioning and off you go.
Here are the interfaces, let it work. Now, of course, that resonates with what you were saying about skills. I imagine that as a good South African company, JD Switchgear is looking across the border as well, and I imagine there must be a significant opportunity for this kind of package solution across the borders as well.
I think it is fair to say that about 60% or more
Right.
of all the prefabricated or containerized substations we produce at this point in time go outside the country's borders. We have shipped as far as Australia, South America, Canada.
I like the Australia one, that's fantastic.
South Africa.
That's wonderful. Johan, it is such a pleasure to see you again, and I'm looking forward to the remainder of the series of tutorials. And thank you for sharing your experience with the readers. And I think that's so important because of everything that you've been saying. Thank you so much.
Thank you very much, Ian.